So today, 7.2, we're going to talk about completing the square again. That is what we ended Friday with. So those of you that were gone on Friday, 7.2, completing the square, if you can do what we're about to do, if you follow along and it makes sense, you will be just fine with what you missed on Friday. However, if you're struggling, if you have questions, feel free to ask as we go through, because it is going to be a little confusing since what we're doing today is taking the two pieces that we did on Friday and learning how we can use them together to answer a wider variety of questions than just the ones that are already set up a certain way like we saw on Friday. So the whole point of today's lesson is to take some equation for a circle and put it into the format that we learned on Friday. X minus h squared plus y minus k squared is equal to r squared, where hk is your center, hk is the center, and r is the radius. This is why we're going to call it descriptive form. It describes our circle. There are many ways that you could write a circle equation. We want this form because it's the most useful. It describes the circle in terms of its center, kind of where the circle is, and then its radius, how big the circle is. And really that's all you need, as we found on Friday, to graph the circle. So let's dive right in. The nice thing again about this unit, I told you guys on Friday that we cut it down. This chapter used to involve a lot of other conic sections. Because we've pared it down to just circles and parabolas, if you see an x squared and a y squared, you know it's a circle. In other classes next year, you may get others where there's an x squared and a y squared and it's not a circle, it's an ellipse or something else. But for our purposes, this unit, if it's got an x squared and a y squared, it is a circle. All right? And that means we want it in descriptive form so that we can graph it. To get it into descriptive form, we're going to use completing the circle, what we ended on Friday with and what we were just practicing. To do that, we need to get our x's together and our y's together. So, quick reminder that when I talk about the two sides of an equation, the equal sign is my dividing line. So right now, everything is on the left-hand side of my equation, and all that's on the right-hand side is that 0, kind of holding the place of anything that I want to put over there. Does that make sense to everybody? So when I talk about putting the x's together, I literally am just going to rearrange the left side. I don't need to add or subtract anything, like I don't need to move it, I don't need to do anything to both sides of the equation. I am just going to take the x squared and the 8x and write them next to each other, x squared plus 8x, and leave myself a little space there. X squared plus 8x. The y squared is my only y term. Does that make sense to everybody? There is no other y term, so I'm just going to put plus y squared over here. And now, there are multiple ways to solve these problems. I'm going to put that out there. If you have a question about, hey, can I solve it this way, or can I try this, please ask, and I will tell you if it will work all the time, or some of the time, or if it's really not advised to do that at all. What I'm about to show you is the method that I have found is the most reliable, requires the least amount of mental gymnastics to find the answer. It's the most straightforward, it's the most reliable, least likely for you to make a mistake. So once you've grouped the x's together and the y's together, take any constant terms, so in this case the 6, and move them onto the other side, okay? Make sure they are on the right side of the equation, away from everything else. So I'm going to subtract 6 from both sides. So that at this point I have x squared plus 8x, little blank, plus y squared, and that is equal to negative 6. Is everybody okay so far? All I've done is rearrange the equation a little bit. From there, what I'm going to do is complete the square. All right, she is at sports right now. Like, do you want me to hang on to this for tomorrow, or? It's a reminder. I can take it out. Either way, thanks. Once we've got it in this format, now I'm just going to complete the square so that it really looks like descriptive form. X squared plus 8x plus something would be a perfect square. What does that something need to be for this to be a perfect square?
16.
Okay, how do we find 16? Yep. Half of 8 is 4. 4 squared is 16. So I'm going to add 16 right here so that this is a perfect square. Now, as we all know, I can't just go around adding things to random places in my equation without messing it up. So if I add 16 to the left-hand side, I need to add 16 to the right-hand side to keep it balanced. At this point, the right-hand side is the junk drawer. I'm just stuffing everything over onto the right-hand side that I don't need right now. Does that make sense? I don't care at all what ends up over there. What I care about is this right here being a perfect square. That is the important thing. So x squared plus 8x plus 16 factors into x plus 4 squared. Right? 4 times 4 is 16. 4x plus 4x makes 8x, the middle term. That is now factored, and it's in a perfect square. The y squared is already a perfect square. There's no other y's. I don't have to deal with anything. It's good the way it is. And then once I've got to that point, I'm just going to combine anything on the right-hand side. Negative 6 plus 16 is 10. This is now in descriptive form. Can we all see that it matches what we were doing on Friday? So, thinking back to Friday then, what is my center point of this circle? Negative 4, 0. Those of you that were gone on Friday, the center point is whatever's inside the parentheses along with the x or the y, but it's going to be the opposite because our equation up here is x minus h and y minus k. So the center point here, x essentially minus negative 4. Negative 4 is my x coordinate, y plus or minus 0, it's just 0 there. So my center point is negative 4, 0. Negative 4, 0 right here. Now, the 10 is r squared. R squared equals 10. So r is going to be the square root of 10, or about 3.2. Does that make sense to everybody? So now what I'm going to do is go up, essentially what we've done, again, reminder from Friday, the r is our radius, and so all the points on my circle are 3.2 units, roughly, away from that center point. Finding things at a diagonal is hard, so we're going to stick with the easy ones. Just go up 3.2, 1, 2, 3, and just a little bit. Go down, 1, 2, 3, and a little bit. Go left, 1, 2, 3, and a little bit. Go right, 1, 2, 3, and a little bit. And then connect those dots. Try to make it as circular as possible. And we're done. Does that make sense to everybody? Now I'm going to show you one more example pretty quickly, and then I'm going to have you guys try one. Letter B. Letter B, I need to get the x's together and the y's together. So just all kind of in one big step, I'm going to add 4x to both sides. I'm going to subtract 12y from both sides. And I'm going to subtract 12 from both sides. So that, over here, these are gone, I'm left with just equal to negative 12 on the right-hand side. And on the left-hand side, I'm going to have x squared plus 4x. Leave a little blank. Y squared minus 12y. Leave a little blank. Is equal to negative 12. Does everybody see what's going on here? Get the x's together so that they're ready to become a perfect square. Get the y's together. And then just start stacking everything you don't need on the left, or sorry, on the right-hand side. So let's try it. X squared plus 4x. What needs to go in there? So divide by 2. 4 divided by 2 is 2. 2 squared is 4. Add 4 here, and then to keep it balanced, add a 4 on the other side. Y squared minus 12y. What needs to go there? A 36. So plus 36 on the other side. So again, the benefit of this is I can put whatever numbers I need over there to get my perfect squares, as long as I do the same thing to the other side. Now, x squared plus 4x plus 4 is going to factor straight into x plus 2 squared. Y squared minus 12y plus 36 is going to factor into y minus 6 squared. And then I'm going to have the whole thing equal to 28. Negative 12 plus 4 plus 36. It's going to be 28. All right, let's see how we're doing with this as far as just describing the circle now. Justice, what is the center point for my circle then?
-2, -6.
Ooh, real close. You switch the x, switch the y also.
-2, 6.
-2, 6. Does that make sense to everybody? This is the first case where we switch both of them. We often didn't switch the y's. But since they're both in their own sets of parentheses here, they're both grouped with their variable, it is going to be the center point of -2, -6. And then my radius, Alyssa, what is my radius close to?
5.3.
So again, this is just a little bit more than 25. So we're looking at r is the square root of 28, which is about 5.3. Can everybody graph that circle? Left 2, down 6, up 5.3, down 5.3, left 5.3, right 5.3. Connect the dots. There's your circle. I would like you guys to try number 3 at this point on the homework, not on the notes. Number 3 on the homework. Did I not switch it? I didn't. I said 1 and then I didn't actually move it. I was thinking this looked different than what we had before. So, I apologize. Move that one up, you guys. I thought this was looking different than what we had last period. There we go. Move that up to +6. I really need to get in the habit. You guys, when you catch me making mistakes, I need to hand out candy for them. So I'm going to start today. I keep meaning to do that. Since I have some and I haven't really been handing it out because there's just not enough here. So if you catch a mistake that I'm making, I will try to hand out candy for that. All right, go ahead and try number 3 on the homework. Number 3 on the homework, I'll come around and answer a couple questions. just start putting everything together that's inside those groups. You're just about there. And then double check to see if there's anything else that comes out. Questions on it? Again, you're welcome to work together, you guys. Ask each other questions, ask me questions. I really want number 3 to be done here before we move on. Make sure we've got this. What you're going to do, make this into the square. So leave yourself a little space, because you're going to have to add something. Questions over here? Good. Okay. So those, I believe, are both correct. There's, Alexa,
Yes.
don't forget to take the square root of the number on the right-hand side. And make sure that you're doing the opposites of the coordinates. I think that's the only issue for yours. So I think you just need to take the opposites and then take the square root. That's fine. Looking smaller than that. Okay, the minus 20, when you subtract 20 is over here, so it's a negative 20. Plus 25 would just be 5, and then plus 4 would be 9. So essentially it's going to be 9 instead of 49. All right, a lot of you finished number 3. A couple of you even did number 1 as well. Let's go over number 3 just all together. Make sure we've got this. See how we did. Let's see. So, Jocelyn, sorry, S. What did you get for? Let's just skip kind of to the end here. What did you get for your center point for number 3?
4 and negative 1.
4, negative 1. Anybody get something different? I believe that should be correct. You ended up with your x minus 4 squared and your y plus 1 squared. Actually, let's write that out. X minus 4 squared, y plus 1 squared. And then that was equal to, let's get somebody else Brendan, what did you get for the other side of the equation? Once you've grouped everything, you've added it all together, what was on the right-hand side of the equation? 4? All right, and so let's get somebody else. That's, I believe, correct, unless somebody got something different. Destiny, what does that mean your radius is?
2.
That is correct. Radius is 2. So then to graph this, you should have all ended up with a graph at positive 4, 1, 2, 3, 4, down 1, and then up 2, down 2, left 2, right 2. There's our nice little circle. Any questions about that one? You feeling okay there? All right, switch back over to the notes then. That is the majority of today's lesson. There's now just a few extra little pieces that I want to go over that are going to take us a little bit of time. We'll try to get as much done as we can here. The next issue is the inequalities. Why don't we look at D actually? Look at D instead of C. We'll come back to see if there's time. Letter D, x squared plus y squared plus 10x minus 11 is less than 0. Group the x's. Are they already on the same side? So maybe another way to ask this, is this going to be an x squared plus 10x or an x squared minus 10x? Plus 10x. We're just putting them next to each other. They're already on the same side of my inequality. Leave yourself a space. When you group these together, you guys, leave yourself a space. You know you're going to have to put something there. So leave a little gap. Draw a little bar. Y squared. Are there any other y's? No. So we're good there. And then add that 11 to both sides. So plus 11, plus 11. The whole thing is less than 11 at this point. Now all we have to do is decide, all right, what do I need to put in that blank to make this a perfect square? What's it going to be? Right, so we're going to need 5 squared, which will be 25. So I'm going to put that in here. Plus 25. Plus 25. End up with x plus 5 squared. How do I decide that this is a plus 5 and not a minus 5? 1 second. So the idea is if we want that to be a 10x in the middle, we're going to stick with the same sign. The same sign as the middle term. Now, Caitlin, you had asked, how do I know it's a 5? The 5 is from half of whatever the middle term is, which should be what that squared is what we're adding on here. Does that make sense? And the whole reason, the whole purpose of this, you guys, is to take that x plus 5 and know now, let me get just a blank piece of paper. Here we go. I really want us to understand where this is coming from. The x plus 5 squared, if I multiply that out, you do not need to write this in your notes, everybody, but look up here real fast. If I actually do x plus 5 times x plus 5, I get x times x, which is x squared. I get a 5x, and I get another 5x. Those two together bring back my 10x that I started with, right? And then the 5 times 5 at the end is the 5 squared, or the 25 that I added in there to make it factor into what I want. Does that make sense to everybody? That is the whole point here, is if I pick the right number here, it factors into what I want it to factor into. Is everybody clear that I could add 16 here? I could add 16 and then it would factor into x plus 2 times x plus 8. That would be fine, but it wouldn't help me get to descriptive form. I would have 2 x's now, which is still the issue. I want 1 x inside something squared. So I pick half of 10 and I square it so that it factors perfectly into the same thing twice. The y is already good. I don't have to mess with that. plus y squared less than 36. Convenient. I have my vertex, or sorry, my center point, -5, 0. And my radius is 6. Is everybody good with where those came from? All right, so -5, -5, 0 right here. Radius is 6, so I'm going 6 to the left, 6 to the right, 6 up, and 6 down. Now, before you draw this in, if you're already drawing it and you're using a pen, you may have had an issue here. Is this a solid or a dashed line? Dashed. If you drew it solid with a pen, just draw a little label over it, say dashed. I'll give you credit. But we want to label that. We want to make sure that this is a dashed circle, which is even harder to make look circular than a regular circle. Make it as clear as you can. Now, when I want less than the radius squared, do I go inside the circle or outside the circle? Inside is a smaller radius, smaller numbers than my radius. So I'm going to shade inside the circle here. All right, we're good there. I'm going to skip C for now. I'll put the answer up for C if you want to add it to your notes in a little bit. But again, we've practiced a few of those inequalities before. So look down now at F. Let's do F instead of E, and then I'll try to upload 2 videos that have a different set of problems. You really only need one of these. F, x squared plus y squared plus 11x minus 10y plus 125 over 4 equals 0. We've got this fraction here. Don't worry about it. Solve it exactly like you did the rest of them. So group the x's, group the y's, move that weird fraction over to the other side. X squared plus 11x, leave a space. Y squared minus 10y, leave a space, is equal to, subtract that 125 over 4. I have now got it set up the way I want it, to where when I complete the square, I'll end up in descriptive form. So I need, okay, right here is the issue. Why this one gets its own example. What's half of 11? 5.5, or 11 over 2. I would stick with 11 over 2. If you use 5.5, it's not wrong. Okay? I'll check and see if anything says specifically fractions, but either one should be fine. 11 over 2 is what we're going to put in here because I want to end up with x plus 11 over 2 squared. So I need to do 11 over 2 squared. 11 over 2 squared happens to be 121 over 4. 11 over 2 times 11 over 2. Now the nice thing is, look what happens over here. Those two fractions are going to add together very nicely and come up with something that is a not fraction, a whole number. Here though, I still need to deal with the y's. Negative 10 divided by 2 is negative 5 squared. I need to add 25 to both sides. So that this factors into y minus 5 squared is equal to, I end up with negative 4 over 4 plus 25, or essentially negative 1 plus 25, which is 24. So x plus 11 over 2 squared plus y minus 5 squared is equal to 24. You can set it on my desk. At this point, that one's done. They don't have us graph it. If you needed to, again, 11 over 2 is a little bit more than 5, a little bit less than 6. Well, exactly halfway between 5 and 6. And then you'd take the square root of 24, get your radius is a little bit less than 5, go from there. The last thing that you need to know for tonight's homework is actually something that I think you all learned last year, but just in case. They say show that the circle with the equation this is congruent to the center, or to the circle with center at 0, 0, and a radius of 5. So I want you all to write a sentence description here as a little reminder to yourself. The sentence is, all circles with the same radius are congruent. So, if you have a circle that has a radius of 5, it is the same circle as any other circle with a radius of 5. All we're doing is moving it around. Does that make sense to everybody? Since circles literally have just one dimension, they have a radius. That's all that defines the size of a circle. You can put it wherever you want. If it's got the same radius, it is congruent. So what G is asking you to do is put this equation in descriptive form and figure out what its radius is. If its radius is 5, then it's congruent to the other circle, which they say it should be. You're just proving that. So literally you're doing the same thing you've been doing so far. You're just finding the radius of this circle. Does that make sense to everybody? Just like all squares are congruent to all other squares, all circles are the same, congruent to all other circles. So why don't you guys take a minute to do number 7 on your homework. Take a minute to do number 7 on the homework. The homework questions for tonight are the odds and number 6. Okay? The odds, and then I'm adding in number 6 there. But start with number 7 so you guys get a little bit of variety as you practice.